Okay, we're going to call this video How Many Points Determine Stuff. Here's what I mean by that. How many points determine a line? Quick. Okay, everybody knows 2 points determine a line. And what that means is given any 2 points, there's exactly one line that contains them. Okay, here's a more interesting question. How many points determine a plane? 2 is not sufficient. Given any 2 points, draw a line connecting them. Now, any plane that contains that line will pass through those 2 points, like this one. Okay, but given a third point, imagine rotating the plane I've drawn about the line until it passes through that point, like that. So it turns out 3 points determine a plane. And by the way, that's why tripods are used to hold cameras and things steady. Okay, how many points determine a 3-dimensional space? Well, by analogy, 2 points determine a line, 3 determine a plane, so 4 points should determine a space. Okay, let me draw one for you. There, okay. How many points determine a parabola? Well, everybody knows the equation of a parabola can be written in the form y equals ax squared plus bx plus c. And there are 3 unknown coefficients here, so we should need 3 points to determine a parabola. So let's take these 3 points, for example. Can you imagine the parabola that passes through them? Looks something like this. Okay, by the way, there's a nice way to write the equation of this parabola down without having to solve a 3x3 system. Let's call the points x1, y1, x2, y2, x3, y3. Well, there's a determinant equation of this parabola. Okay, in the first row of our determinant, we'll put y, x squared, x, and 1. This will be a 4x4 determinant. In the other rows, I'll put all constants. If I put all constants in the following rows, then by cofactor expansion along the top row there, this determinant should be a linear combination of y, x squared, x, and 1. So it will be the equation of a parabola. Okay, let's fill in the remaining rows with constants like this. Okay, the reason this parabola passes through the 3 given points is pretty simple. Take x1, y1 for example. If you plug that into the top row where the x's and y are, you'll make the top row look exactly like the second row. And when 2 rows of a determinant are equal, the determinant is 0. Okay, if you've forgotten all that, go back and study determinants some more. Anyway, if you believed me when I said 3 points determine a parabola, you were wrong, and don't believe everything you watch on YouTube. Okay, how many points determine a set of 7 points? 7. Okay. How many points determine a circle? Well, if you were thinking 1 point determines a circle, please stop watching this video now. Lots of circles pass through that 1 point. If you were thinking 2, still not so bright. There are lots of circles passing through those 2 points. If you were thinking 3, pat yourself on the back. Given any 3 points in the plane, they determine a circle. Okay, let's prove that. Okay, let's take these 3 points and connect a couple pairs of them up with line segments here. Take one of those lines and draw the perpendicular bisector. Do the same with the other. Wherever those perpendicular bisectors cross, that's going to be the center of our circle. The reason for that is simple. Any point along the perpendicular bisector of a segment is equidistant from the 2 endpoints of that segment. So this point is equidistant from the endpoints of that segment and the endpoints of the other segment. So those 3 blue lines there are equal, and we can use the length of each as the radius of a circle, and it will pass through those 3 points. And by the way, this circle is called the circumcircle of that triangle, and there's the radius. Okay, let's move up a dimension. How many points determine a sphere? Well, the equation of a sphere looks like this, and you can see it has 4 unknown coefficients, so we should need 4 points to determine a sphere. And that's true. Given any 4 points, there's 1 sphere that passes through them, as long as no 3 of the points are, as long as all 4 of the points aren't coplanar. And by the way, there's a neat way to get the center of this sphere. If you take 2 of these points and connect them up to make a line segment, Draw the perpendicular bisector of that line segment. Well, what do we mean by that? We're in 3 dimensions. It turns out the perpendicular bisector is a plane, the plane that passes through the midpoint that is perpendicular to the segment. Do that with 3 line segments. The 3 planes will intersect at the center of the sphere. Okay, here's a question I didn't find any information for online. How many points determine a square? Thought it might be interesting. Well, it turns out there's not a great answer to this question. Let's take 5 points, for example. Do 5 points determine a square? Well, given this set of 5 points, it turns out, yes, they determine a square. There's only one square that passes through those 5 points. However, that's not true for every set of 5 points. Take that set. There's no square passing through those 5 points. No, that's a triangle you're thinking. Take this set of 5 points. Well, there's lots of squares that pass through those 5 points. So they don't determine a square either. Really getting my money's worth here with this PowerPoint. Let's watch those squares fly in again. Okay. Well, maybe the problem with these diagrams is in each one I have 3 points that are collinear. Maybe we can determine how many points we need if we add the restriction that no 3 are collinear. Well, think, how many points could you possibly have on a square so that no 3 are collinear? Got the answer? Right, it's 8 because you can have at most 2 per side and there are 4 sides. For example, take these 2 points, these 2, and these 2. No 3 points in this picture are collinear, so they probably determine a square, right? You couldn't possibly get more than one square through those points. There it is. Well, you're wrong again. There's the square. There's the second square that passes through those 8 points. Alright, so it turns out it's not a very good question, how many points determine a square. It's kind of silly actually, and that's why I didn't find any good links online. Okay, last question. How many points determine a cat? Well, if you're like most people, you're probably thinking 9. Okay, there's a cat passing through 9 points. However, you're wrong. It's not. Okay, thanks for watching.